Hello, friends. We are back with episode 215 of the Our Weekly Highlights podcast. Sorry for missing last week, but sometimes the day job end of year stuff got me wrapped up in all sorts of fun stuff last week, but I'm back once again and really excited to close out the year strong here, so to speak. We got more awesome R content that has been shared on this week's Our Weekly issue to talk to you all about. So my name is Eric Nance, and I'm delighted that you joined us from wherever you are around the world and wherever you're listening. And keeping me honest as always is my awesome co-host Mike Thomas, who just had to endure yet more rants in our pre-show here. And Mike, how are you doing today?
Doing great, Eric. Hoping to wrap up the year strong here with the Our Weekly Highlights. Heading into the holidays, it is frigid out here on the East Coast in the U.S., but we'll try to keep everybody warm.
That's right. I was wearing my other jacket here downstairs until we got started with this because it is a bit chilly here in the good old basement here. We don't exactly have a huge budget here for recording here. We'll get into more on that later. But nonetheless, we can talk about some awesome stuff that doesn't need a budget, so to speak, because it comes for free for all of you on this week's Our Weekly issue and has been curated by Sam Palmer this week, another one of our somewhat newer curator, but he's actually been on the team for over a year, and he's been tremendously helpful as always with this issue. And he had tremendous help from our fellow Our Weekly team members and contributors like all of you around the world of your pull requests right at our ourweekly.org site. So let's get right to it, because the world of artificial intelligence, development of large language models moves at a breakneck pace throughout the years. And one of the nice things that we've seen come out in the data science community to try and cut through all the fluff of this, so to speak, because believe me, there's a lot of fluff out there. Hate to bring up LinkedIn from time to time, but there's a lot of slop on there with AI, so you got to watch it there. I kid, not really. But one of the things that has been helpful is the recent effort launched by Posit called the AI Newsletter, which is authored by Sarah Altman and Simon Couch. Both have been really involved in developing LLM technology and packages over at Posit. And they give you the straight scoop, so to speak, on a lot of the newer developments and a lot of the practical issues that you may hear about, but maybe want a more robust take on, especially from the data science perspective. So their most recent issue that came out earlier in the month, the December 5th. And in this issue, there are a couple of cool things that caught my eye. First of which, as I mentioned, these models are rapidly evolving, and there are some new releases on the frontier providers. And I guess somewhat not surprising, but yet it's still interesting to see that from Anthropic's side of things, the new Claude Opus 4.5 model has been deemed by Sarah and Simon here to be the best coding model available according to their benchmarks, which does kind of track from some of the things we've heard in the various community members here that are in the world of LLMs. Seems like Claude has been one that most software developers in general turn to generate their programming code of choice. And it's getting really nice with our code, as I've been playing with it a bit here and there in Positron Assistant. So I'll certainly be eager to try Claude Opus 4.5. And it does sound like they are working on the pricing to be a little more competitive compared to maybe some initial releases. So that's something to keep in mind too. Which does remind me, there's another part of the post that kind of clears up, which can be a confusion for those new to the world of frontier LLM providers. There's often two ways to pay for these services. One of which is that you literally sign up for an account on these services and pay a monthly fee. You may pay it yearly, but it's a static fee. But then there's also the API token method, where you pay for what you use in terms of API tokens. In general, especially if you're new to this, a lot of folks, myself included, recommend you go the API token route as you're just getting your feet wet with things, and then maybe turn to the more rigorous account subscription for times that you really need it. But there's lots of great information in the post on where you can learn more about those choices. The other model that got talked about here is Google's recent update to Gemini, which I know a lot of people have been using because I believe Gemini is actually free to start with to get your feet wet. But they have a new release called Nano Banana Pro. Who knows what they use to name these things, but I'm sure that generates some fun images. But what was interesting in this post here is that they took a little bit of a challenge here and saw that it might actually be helpful in terms of being an image model. That's what this one is, that can generate interesting and at least semi-clear technical diagrams of software. So in the blog post, you'll see when you click on this after listening that they asked it to create an infographic explaining how the Elmer R package works. And it looks like a pretty solid graph. Certainly there may be some questionable choices on where the arrows are going in terms of their layout, but I could see this being kind of neat if you don't want to code up something in those open source kind of diagramming software or the other diagramming software or software that's proprietary. Maybe an LLM can ingest kind of your overall code base and help you do that. So I'll take that note of that for future developments and the like. But yeah, there's definitely more highlights here in terms of other interesting developments. The other one I'll highlight before I turn it over to Mike here is that they have been, the POSIT team has been regularly benchmarking how well the LLMs are generating R code, because there are some nice packages that they've been developing, Simon especially, such as the Vitals package, and then using kind of a built-in, you might call a test case called ARE, to run on all these models and see how well it performs. And now, instead of just relying on the blog posts to come every so often to summarize the performance, they have a fun little shiny app that we'll link to in the show notes that compares the model performance, and you can choose as many as are offered here. And there's quite a bit offered here. But when I looked at it earlier this morning, preparing the show notes here, it definitely shows that Claude Opus is the leader in terms of getting the percent correct in code generation based on the truth, so to speak, in this R, scenario, followed by GPT-5 and then Sonnet 4.5 and the like. But you can add in like the older models, and you kind of see the evolution of how well or maybe not so well some of these models are performing. So great little tool to bookmark, not just for performance, but also the ratio of cost to performance and getting the nitty gritty on pricing details, which if you're in an organization might be really important, or just important to you, so to speak, if you're paying out of pocket for this. So really nice app here, straight to the point, nicely done with BSLib and the like. So definitely bookmark that if you're new to this space. But yeah, I always enjoy reading this when it comes out every few weeks or so. But Mike, what did you think about the roundup here in this newsletter?
Yeah, the end of last month, we saw a ton of activity in sort of the closed source, frontier model updates. That Gemini 3 Pro update, I think, kind of rocked the world. I think it sort of threw Anthropic and ChatGPT, maybe OpenAI, for a minute, but I think that their responses between GPT 5.1 Pro and now Claude Opus 4.5 have been pretty strong as well. And I've also been experimenting with both a little bit and kind of concur that Claude Opus 4.5 is the best for what we're doing day in and day out with R coding and Cordo type of stuff. Some of the stuff that I was experimenting with Gemini 3 Pro was good. I think maybe like a little too verbose, a little too researchy, and a little less targeted. But I think that there's probably some fantastic applications as well. And the pricing model changes is pretty interesting. It sounds like Anthropic actually increased the price of like their smaller Haiku model and decreased the price of Opus. Kind of causing the cost to converge towards the balanced Sonnet, other sort of pricing model that they have. So it's interesting that the highest performing supposedly model with Opus is now sort of one of the cheaper sides, and it seems like that's going to be a bait and switch, like just to get you in, right? And then ramp up the cost eventually once you get hooked. But we're pretty hooked on Opus, so they'll probably have us for a while. And that one thing I haven't explored, but glad that the Posit team did in terms of Sam and Sarah in this article, or Simon and Sarah, excuse me, is explore sort of these image models as well and get into multimodality here with Gemini's Nano Banana Pro. And one of the things I think that they found interesting compared to every other image model that I've seen thus far is it's not necessarily throwing out images that have like junk text in them and wingdings and stuff that looks like it's from another language. I saw something going around on LinkedIn or Blue Sky maybe, where there was an image in a research paper that was published in the prolific science magazine Nature. I think that was like a total AI junk slop. Has since been retracted. I think it was a research paper on autism, pretty serious stuff, and been retracted because it was, I think, found to be just half AI generated, or at least the diagrams were. And if they used Nano Banana Pro, maybe their junk science wouldn't have been discovered, or at least not as quickly.
Oh boy!
So I don't know if
makes
that's a
you
good
both
thing.
happy and sad at the same time. I don't know.
Yes, exactly. But Sarah and Simon did find an interesting use case for these the Nano Banana Pro image generation models and their data science workflows in terms of generating what they're calling coherent, sometimes technical diagrams, which in a lot of our repositories and a lot of our work and documentation that we do at Catchbrook, we're almost always creating workflow diagrams, technical diagrams that are accompanied with the code and the software that we're creating. And there's great tools out there like Mermaid.js and things like that, Excalibur, that allow us to do those things, but it does take some time. So if there's the potential for Nano Banana Pro to be able to speed that process up, or maybe even just help us iterate, that's pretty interesting. And the other part of, I think, the article here that they shared in the newsletter is some additional updates to our packages in terms of the Vitals package now has a 0.2.0 release, so still very early in its life, but that's a really cool package for doing evals and evaluating LLM tools using Elmer. So 0.2.0 is now on CRAN as well. And yeah, as you mentioned, Eric, that Shiny app that they have developed to track performance in terms of R code generation and the accuracy of R code generation across these new frontier models is really, really cool. I think it draws data from using the Vitals package as well, and I know they try to update it regularly. That's something that I'd seen Sharon Mocklis do over on Blue Sky, and not a lot of other folks trying to do, at least in terms of our benchmarking. So for those of us that are still developing in R and haven't switched everything over to Python, this is fantastic, because most of the benchmarking that I've seen thus far in terms of code generation is just around Python. And we've been using, or I've been using the API model, pricing model for all of these services for a while, but I think it's probably time that I consider maybe the all-in monthly cost, because that may be beneficial, because we have caps on most of our APIs where I get a notification every time we use $5, and that $5 notification is starting to ding like every other day or every 3 days. So probably time to consider that all-in monthly cost. But it was a great way it has been a great way to dip our feet into trying to leverage these in our workflows.
Yeah, I think especially when you get into more of the agentic side of things and you're not just doing simple code completions or simple answers to cryptic JavaScript or XML-based parsing like I've done in the past. I know people are trying to build, I heard a story from another colleague at a different company, just as a challenge, try to build like an internal version of a Stack Overflow. And it worked pretty well. But cool. I don't think just the API usage was going to cut it. It was very much an agentic thing. But that just shows you just how far people are pushing these things. And like I mentioned before, generating full-blown Linux distribution configuration files for it in a couple hours versus like 5 weeks it might take somebody new to roll the Nix or whatnot. So it's this agentic flow is happening, and I'm hearing code and cursor being used quite a bit in those situations. But I will say, back on the API front, if you want something where you can kind of pick and choose the models, but in like one overall platform, Open Router has been really helpful to me. It helps you, pick and choose between, say, OpenAI's models, Anthropic's, Google's, and others. And then you just basically give your service account credentials for these API keys into Open Router, and they'll take care of the rest. So some tools can benefit from that, where you just want to you don't want to have to hop back and forth to like 5 or 6 different services. You want to put it all in one place. It's not meant to be free advertising. I'm just saying it actually works pretty well. So you might want to check that out. If you're using more than a handful of these at a time, it can be a lot to manage, especially if someone new like me. So yeah, lots of great developments here. And again, really great to see this Elmer ecosystem just grow exponentially. We learned a lot more about this in recent conferences I've been a part of, both the Gen AI Day for our pharma, that we have the recordings on YouTube, and some great content that will be on YouTube soon from our recent our pharma conference in respect to how we're leveraging Elmer and the like. So good times to be had. And speaking of good times, geez, Mike, there's a little competition out there in the world of podcasting, apparently. But no, it's all in good fun, of course, because our friends at Posit have been hard at work and developing some novel podcast content called The Test Set. Sounds like you've had a chance to listen to a few of these, and maybe you could take us through what your impressions are of The Test Set.
I have. I think they have a higher budget than we have, Eric. They've got some really nice backgrounds, and it's very well produced. It's great. I think originally it sort of started out with Michael Chow as the host, and now they've brought Wes McKinney in as a co-host on most of the most recent episodes, I should say, and they've been fantastic. Really great deep dives into the backgrounds of many sort of prominent figures in data science across both R and Python. Folks like Julia Silge, you would know, James Blair, who works at Posit as an engineer there, and Kelly Bodwin, most recently, who I believe is a professor of statistics in data science at Cal Poly, which was really interesting to get her perspective on how she teaches and sort of different strategies that she has, as well as her background coming up through data science. So I have really enjoyed it thus far. It sounds like they have some pretty exciting guests on the roadmap for 2026 as well. Folks from DBT, Shopify, Astral, Mode, Meta, and a bunch more. So I can't get enough of, which maybe is unhealthy, listening to data science podcasts after I'm done working for the day and walking the dog and mowing the lawn on the weekends. But I have long been bit by the data science bug and started out probably listening to the original R podcast by my co-host here, as well as Shiny Developer Series, and just ingesting as much as I possibly can. So I really enjoy these conversations. It's as a way, maybe for somebody who works kind of fully remote in my team, it's a way to connect with the greater, data science ecosystem and folks that are out there, greater data science community, hear what everybody's thinking about, interested in, and working on. So I appreciate Posit making the investment to put this together and produce it and share it with the world.
Yep, it is on my catalog on my little phone here to catch up on the back catalog. I did listen to a little bit of one of the episodes earlier this week with Minnie Chinchiganai Rundell on her experiences with teaching in the world of data science, especially in the advent of LLMs. And she has some interesting takes on how she's leveraging the novel technology to make running a course easier, but also kind of the real fundamental issues with students now growing up in this new age, which is almost like, when old timers like me were growing up with the internet just starting in high school and college, and how that revolutionized my workflow there. But yeah, great perspectives, great lineup of guests. Like I said, it must be nice to have a positive budget instead of a pseudo negative one like what we have here. But hey, fair play, and they got the right minds behind it. So I'll definitely have that in my podcaster of choice, feeder of choice, because it is both on YouTube and in your favorite podcast provider. Certainly, I would say definitely audio friendly. I think, like you said, Mike, my consumption of content in the world of data science and open source software development, I am often doing something else while I listen. And then the challenge is when I hear this great insight of like being able to hit pause, write it down, or at least jot down a link to follow up on. But there are some creative things, I'm sure, in that space. But yeah, test sets going on strong, and look forward to seeing what else they have in their episode pipeline.
Good podcast name too.
Yes, naming things is hard. It was easy back then because there was no R podcast before, so I got the easy
Doesn't
one.
get better than that. Yes,
doesn't get better than that. Someday, I tell you, I'm going to get that one back up and running again. I've got plans, buddy. Got plans. So I know, Mike, you've been talking, especially in your recent conference talk, about, bilingual type of data science, especially from the R and Python side of things. And there was a post a few weeks ago by a prominent member of the R community, Klaus Wilk, definitely caused a bit of a stir about his take on why Python was not such a great language for data science. Certainly a mix of, I would say, things I nodded my head on, and some things I'm like, yeah, that sounds like just a bad experience, and maybe with a better environment management or things like that, it might have gotten better. But it definitely got a lot of people talking, a lot of people thinking. And our last highlight here is definitely from one of the leading thinkers in the space of alternative ways to do data science, John Carroll, because he was inspired by Klaus' post to look at a language that you may on the surface not expect to be great with data science workflows, but in John's mind, it's actually coming a pretty long way. What language are we talking about here? Haskell. Haskell is definitely kind of towing the line between a lower level language and maybe some interpretable type of components to it. If my memory serves me correct, I believe Haskell is the basis for the pandoc utility, which pandoc is what we use quite a bit as the back-end converter system, going from like Markdown over to HTML or to open office formats and whatnot. I could be wrong on that. Someone will have to fact me, check on that, and I'm sure they will. But that's where I first heard of Haskell. But I do know that there are a lot of different use cases for it, and up until recently, John has been using this Haskell in a lot of interesting kind of advent of code challenges, but he has seen some interesting traction in the world of Haskell with respect to data science, such as the Data Haskell project, which is meant to be kind of a curated organization of various packages in the Haskell ecosystem in tutorials and in the future kind of learning environments to get your journey off the right foot on using Haskell for data science. Now, there are some key differences between Haskell and the languages we're familiar with, such as R or Python, that are definitely worth taking a note of, especially if you're new to the syntax, that definitely would take some learning. One interesting one is that we're so used to using parentheses to feed in like the name of the function, and then put within the parentheses the name of arguments. No parentheses in Haskell, it's just spaces. So that takes a little getting used to when you're reading that the first time, even for a simple summarization function or whatnot. But there are some things that are kind of similar, such as it has the concept of lists, but lists in Haskell are kind of more like vectors in R, where they kind of need to be the same type of each element inside. You can't mix and match like an integer and a character in a Haskell list. They must be a single type. But one interesting thing is, ever since, a couple of years ago, R now has the native pipe operator, obviously inspired by Magritte and other packages. Haskell has the same pipe in its system too. So if you're used to pipe workflows, more power to you. You can use it. There are some nuances though. As you go from left to right, it'll pass the left side of the pipe, side of the pipe chain over at the end of whatever's on the right side, as opposed to the first argument of whatever you're doing on the right side. Again, you may not run into that unless you are really taking this for a spin, but that is something that you might want to look into. But going back to what Claus had mentioned about, why he felt Python wasn't a great language for data science and what attributes of R do make it a great language for data science, there were 4 key pillars that Claus talked about. First was non-mutability, or basically the idea of keeping things kind of static and not modifying without, guardrails behind it with respect to objects and results of functions and whatnot. Having built-in concept for missing values as well as vectorization, and also hooks for non-standard evaluation. So in the remainder of John's post here, he talks about how Haskell actually also addresses these 4 pillars. First of which is the non-mutability, and this is where Haskell is what we call a strongly typed language. That may be a term not familiar to you if you've only done R or Python work, but basically what strong type kind of means in this context is that it is really difficult to change, if not impossible, the types of objects that you work with, unless you use the kind of guardrails or functions that the language provides. This is where you can't really change like a character to a number easily or things like that. And Haskell does share those traits of being a strongly typed language with some recent advancements kind of at this intersection of R and strong type languages to enhance R itself, such as the Vapor framework from John Kuhn, Type R, and R lang checks, and even some other efforts like that. But Haskell has it all built in. So that's one nice feature. And it also has the concept of missing values. You do have to, I think, tap into another package for it, but you can use built-in constructs that have an interesting label, such as just or nothing. So this one kind of made my head scratch a little bit, but there's an example here about a list of numbers 1 to 4, and then a list with, quote, just 1, just 2, nothing, and just 4. And then there are checks to see which one has missing values and which one doesn't. And it does detect which one has a missing value. And that you've got to do, if you want to do a summarization of that, where it just had 1, 2, and 4, you have to exclude the nothing from that list before you can do it. There's no na.rm type of argument in Haskell that we're seeing here, but that's pretty interesting. But what the other interesting thing is that while it doesn't have built-in vectorization, it does have great support for iteration via the map kind of constructs that we use from Per and the like, but they come built in to Haskell. So there's some nice examples of doing those kind of mapping operations. But then the part that John thinks really shows some great promise is the non-standard evaluation, where you can do a lot of interesting dplyr-like constructs with Haskell, again, combining that pipe operator to do things like filtering and doing things like changing variables or deriving variables, as they call it. And you can print out the data frame in a nice text kind of display, not too dissimilar to when we print out a tibble or something in the world of R, and of course in Python with pandas and the like. Some pretty interesting things you can do there. Now, again, the syntax is quite different. It's not like I'm going to Haskell anytime soon, But it is interesting to see that some languages that you may not expect do come with either some built-in tricks or can tap into its own package ecosystem to do some data science operations. And it does sound like they're trying to beef up the resources on the use of Haskell for data science. I think John himself is contributing some small pull requests in different repositories, and maybe the Haskell world of data science kind of takes off in 2026. Who knows? But as usual, open source, great to have choice and great to learn something new along the way. So if you got some downtime in December, maybe give Haskell a spin. Who knows?
Yeah, I think Jonathan has been one throughout the years of R Weekly to explore different options in data science programming. I think that it may have been him that explored APL, a programming language.
That's right. We covered that. That was a fun one.
I remember that correctly, which just kind of used like arbitrary random characters that didn't necessarily make a whole lot of logical sense, but worked just fine. And I think maybe that was the point of APL. Haskell is definitely a little easier to read and consume for me. And it sounds like a lot of ground has been broken through this Data Haskell project, as well as this data frame package within Haskell that allows it to be quite a bit friendlier to data scientists as well. I think that familiar pipe operator is really interesting when you take a look at the documentation in terms of how it lines up with maybe your familiarity in R. I think one of the big differences is that instead of using parentheses for function calls, you actually use a space. So in R, you would do sum parenthesis x close paren, and then in Haskell, that would just be sum space x as well. And yeah, as you mentioned, Eric, the whole immutability concept as well, which Jonathan gave in the blog post, this example of if I have an R vector with 3 elements that I define using the lowercase c function, I can sort of overwrite the second element if I just assign some value to the vector with square brackets after it that have maybe the number 2 in it if I'm trying to overwrite the second element. And that's really difficult and kind of impossible to do. Not necessarily impossible, but they make it difficult to do in Haskell. It's kind of off limits. You have to go through quite a few hoops to be able to update a single element within a vector. So that's one interesting, and I think that leads to one interesting difference, and I think that leads to the concept of immutability and strongly typed languages. And Haskell also has some really strong sort of support for handling missing values as well, which can always sort of be this tricky thing in R where we have just NA, and then we also have NA underscore for all these different types, character, number, things like that make it difficult. And if you have to deal with missingness, Haskell may potentially do a better job. And as you mentioned, in terms of performance, it lacks, this built-in vectorization. It's not an array language, but since it's compiled, it really compensates for this using some pretty nifty compiler tricks, it seems like, which is pretty cool. And it also aligns with non-standard evaluation type of features that we see in things like dplyr. And there is actually a great article, I believe, in the data frame docs for this Haskell data frame library that does a comparison between dplyr on how you would filter rows using the dplyr filter function, and then compares that to what you do in Haskell, which looks to me just kind of on the outset of sort of this combination between R and Python a little bit. There's an @ symbol that sort of specifies data types in the middle of this filter statement, but not that far off. So maybe an interesting thing to look at if you're one potentially doing advent of code or something like that, where you're trying to explore, different edges of the data science ecosystem and maybe trying different languages that you haven't picked up before. Haskell might be a good one to take a crack at, particularly now that this data Haskell ecosystem is available and this data frame package has been, has had the tires kicked on it, it seems like, for quite a while now, and seems like a great option. So great blog post from Jonathan. Always very interested to see how he's pushing the fringes of data science.
Yeah, and speaking of pushing, there was a great write-up in the vectorization portion of his post where you can see kind of the benefits of Haskell kind of having some good compilation tricks, and it can be actually quite fast for things that would be challenging the R itself to compile or to run, such as doing of a huge length of integers. There's a great example of, just reversing the sorting of that and taking literally almost 0 seconds on Haskell side versus over 4.5 seconds on the R side. So while, again, the vectorization isn't quite built in, it does have hooks and compilation that does sound like it's good for performance too. So for those of the need for speed, sounds like Haskell can get you there as well. But speaking of speed, we better speed right through to the end of this because we got other things to attend to, but we won't have time for additional finds. But again, fantastic issue put together by Sam here, and where you can find that is at rweekly.org, of course. That's always where you find the latest issue, as well as links to all the previous issues that, again, wonderful content over the year. And 2025 has been a fantastic year of content, I would say. And we love hearing from you as well. You can always fact check me on what I get wrong in my summaries here, but you can find us or get in contact with us a few different ways. You can send us a little contact submission form, which is in the episode show notes, wherever you're listening to this humble little podcast. You can also get in touch with us on the social media outlets out there. I am on Blue Sky at our podcast at bsky.social. I'm also on Mastodon at our podcast at podcastindex.social. And I'm on LinkedIn. I'm not causing any AI fluff. You can search my name and you'll find me there. And Mike, where can the listeners find you?
You can find me on Blue Sky at mike-thomas.bsky.social. Or you can find me on LinkedIn if you search Ketchbrook Analytics, KETCHBROOK. You can find out what we're up to.
Awesome stuff. Yeah, I know you've recently completed some really fun projects. We hope to hear about those somewhat soon. But time's our enemy, of course, to write all that stuff up.
And some new R packages on Crayon in the last month that we've published, which we're pretty excited about. Although one is having some issues that we need to update.
The joys of Crayon.
We got the Crayon email.
Right?
Yep. We were good, and then the website that the package interacts with changed. Put up a firewall, like a verify that you're a human type of page, and it broke our download.file function in R, just in case you've been there. If you know, you know.
You know. Yep, that's a bit mean behind in other places many, many times. But nonetheless, very exciting stuff to see contributing open source. And with that, we will close up episode 215 of our Wiki Highlights. And we hopefully will be back with another fresh episode to help wrap up the year next week.